Hey guys, welcome back to AlgoYogi. We are finally at the end of our stack series, and our last problem in the list is 132 pattern. Let's go to LeetCode and wrap this up. Okay, given an array of n integers, nums, if 132 pattern is a subsequence of 3 integers, nums at I, j, and k, such that I is less than j is less than k, and nums at I is lesser than nums at k, not j, k, and j is greater than k. So it's basically, that's why it's called 132 pattern. You can just definitely like assume that first number is the smallest, second number is the biggest, and third number is in the middle. That's the simple way of thinking it out. Then we are given this array nums, and we have to find out if there is a 132 pattern in our array. If there is, return true, otherwise false. So let's see how we're going to approach this problem. So basically, problem is asking us to look for 132 pattern. So this is our array. These are different numbers here, and we need to look for 132 pattern. This is what we are looking for, 132. This means what? This represents ith number, this represents jth number, and this represents kth number. Now here I will be less than j will be less than k, but if you see the numbers, num I is the smallest, and num k is in the middle, and then k is less than num j. This is what we need to find out. We need to find out 3 numbers that satisfy these 2 conditions. Let's check how we're going to do this. So brute force way of solving this would be simply, I'm trying to find 3 numbers. I'm going to use 3 for loops to look for I till the end in this nums, and just also at the same time have these 3 numbers find and satisfy these conditions. So I will be the smallest, then nums k. By the way, k is the integer that will lie basically at the end, but it has to be smaller than the middle number, which is j. So this is the condition. Let me write it down. J and k. Just there is this bit of switch, right? There's a bit of switch here. You can see when we are comparing the numbers. All right. So we're gonna have I. We're gonna have for j starting at I plus 1 to basically n minus 1, and this one is going till the n minus 1, and then we have k going to basically starting at j plus 1 and then going to the n minus 1. Now here's the thing. For this condition that you will have even in this brute force approach is that you are trying to find basically these unique distinct integers that satisfy this condition right here, So when you're looking for, let's say you look for basically at a time, I'm looking at 3 numbers. So for this I, if I choose 3 as my I have possibility of choosing this as my j, this as my k, right? This is the only 3 things that I can choose, and I can also choose one more time this as j and this as k. So this as j and this as k. But to satisfy this condition, I will compare this here, and whichever combination satisfies basically will give me my answer. So this will be of, I'm sure like this is very understandable. This will be of big of NQ time complexity solution. Space complexity is nothing, but time complexity is big of NQ, which is considered like forbidden, like not forbidden, but it's really bad. Like we don't want to ever write a solution that is of that kind of time complexity. If this is the time complexity, we can definitely bring it down to either n square or NQ. No, or linear time complexity, big of n. So let's write a better solution using a stack, more specifically monotonic stack we just used to solve the previous problem. You can check that out. So a monotonic stack basically will have values either in increasing order or in decreasing order. All right. So here there are a few things that we have to be keep in mind, because this is not like very straightforward problem. It's a little tricky, and bringing down the time complexity from n cubed to n is not like an easy game. So here what I want to do is I want to have a stack, and in my stack I will store 2 values, and at the same time, I also want to keep track of the minimum that I've seen so far. I'll tell you why. So this minimum that I want to track is 4. So initially, let's say this minimum is 3. This minimum is 3 because that's the first value that we are seeing in the nums. So current minimum is 3. Let's see this current minimum. Okay, current minimum. This is 3. So in my stack, what I want to do is I want to store values only going from basically in the decreasing order. That's the monotonic stack that I want to have. Why? So this current minimum that I have seen so far, so that this value can act as my I. This can act as my eyes that I've seen before, and that value is actually minimum of these 3 values that I'm trying to find. What are those 3 values? Num set I, num set k, and num set j. And this condition I will check how. So this current minimum is the I that I'm trying to find out. And here in my stack, I want to have values stored in decreasing order. Okay, so that whenever, let's say I can see on top of my stack there is this value that is greater than my current minimum, and it's smaller than the value that I'm just about to append to my stack. So that means I have found this 1 3 2 pattern, haven't I? Let me tell you how. So I will start basically at the first index because I have assigned this 0th index to my current minimum. I'll start at first index, that is, so I'll append 1, then I come to 4, and then I see, okay, top of my stack is actually smaller than 4. So what I'll do is I'll keep popping until the top of the stack is basically smaller than my current value. So this is my current, 4 is my current, so I'll pop 1, then I will append 4. Okay, also remember at the same time this current min I will keep calculating this current min and keep appending basically at the same time. So this 4 so far, current minimum that I've seen so far is 1, right? This 1. So this second index is basically current min, and for 1 it was earlier 3, right? Now next is going to be 2, so I come at 2. But remember, when we are basically like, if we can't pop anything out, we will put this value, but before that I want to have this if condition. What is that if condition? If condition is if there is something in my stack, and that I will check basically after I am like at this position. This is my current number 2. I want to check if there is some value in stack and stack stop. So by the way, this basically came before this value, which is at jth index. So I want to check if stack stop first value is actually greater than my n. Let's say n is basically pointing to the current number, whatever, I don't care. So if this is the case, then tell me, haven't we just found the 1 3 2 pattern? I think we did, because also there is one more thing that we have to check, that so current number is smaller than the top of the stack. So this is basically, this represents j. So its value is greater than my current number, which is k. And let's check for I. So current minimum, which will access by stack top and at first index, is this value has to be, this is a minimum, has to be smaller than k. What is k here? This n. So these 3 conditions, if these pass, that means we have just found the 1 3 2 pattern and we will return true. Otherwise here we will append to our stack basically our this number, which is now 2, and current minimum that we have seen so far is 1, and that's it. Because right now this must have been updated when we visited here, so that we forgot to do. Okay, so I think that will be the entire solution. I know it's a little messy, but it is what it is for now. I'm not going to read the code. Okay, let's write the solution and things will become very, very clear for us. Let's write down. Awesome. Okay, looks pretty good. So as we talked about, we're going to have a stack we're going to have a stack, then we're going to have a current minimum. So current, let's say current minimum, initially we said we're going to assign it the value in the beginning of the stack, which is like at 0th index. So that's my current minimum. For num in nums, and let's start it at first index. Okay, let's start it at first index. All right, so what do I want to do here? What do I want to do here? First thing is, I want to for this current num, let's call it n, that's what we were calling it. For this n, this is my current n. I want to check if, or maybe not if, while, because I want to have a decreasing monotonic stack. So if stack, while stack, and stack stop is actually smaller than, stack stops is smaller than my current n, that means I want to pop from stack, because I only want to store basically bigger values to smaller values, because this current value that I want to see on the top of the stack is basically my j. That is what I want to try and find, and j is basically the biggest value, as you can see right here. This is the biggest value that I'm trying to find right here. This has to be the biggest value. Okay, and if it's on the top of the stack, that means I have seen some current minimum that I will also find on the top of the stack. By the way, this has to be let me zoom in. This has to be the 0th value, by the way. So I will keep popping. I'll keep popping until either it's empty or there is a value that's greater than it. And at this position, after I'm done popping, if there is something in my stack, that means what? Whatever has occurred in my stack so far, which is on the top of the stack, is probably the greatest value, right? Probably the greatest value so far that I've seen, and along its side there will be a smallest value, which is current minimum. We will append that later, but like for now, what I want to do is, and even before I check it, I want to actually append it. So stack dot append. It's just a little tricky to understand. I want to append current num, which is n, and also current minimum that I have seen so far. So I have to update this current minimum. And when do I want to update this? I just want to check for the current number. I want to update it with the previous current min, right? Previous current min is with the sitting with the top of the stack. All right, so I will have current min, or I'll just current min equals to minimum of either this current min or stack stop is accessed like this, and then its second value, which is the minimum. Okay, this first value is the value it has, and this is the minimum. So I will append current minimum and n to it. Okay, clear. Even I'm writing it for the first time, I haven't solved it. So now what I want to do is stack stop is at this value. So this is the j. It has to be greater than my n, and n is my k. Okay, n is my k. So this is greater than my n, and minimum, current minimum that I've seen so far is basically stack -1. First value is the current minimum that I've seen so far, and that is basically has to be smaller than my k. Okay, so j has to be greater, the value at j has to be greater, and k, what is my k? K is n is my k. So if this satisfies, that means I can return true, otherwise false. This, now I'm just thinking about it, it's like this problem is taking so much of my thinking. There's enough thinking. We're all stupid and we're all smart as long as we either know or we don't know. I don't know what I said, but I don't know. Okay, I'm gonna zoom out and let's try to run it. But in my head, I think it should work. But if it doesn't, we'll figure out what's the issue. We did make a mistake here. Okay. We want to have update our current min only when basically if there is something in my stack. Okay, that's one thing. Live debugging, guys, live debug. Well, I just realized that we are actually never updating our current min, and that's because this is the current min itself. This is the current min itself. So we are basically, this is the current min so far, so we have to compare it with the current number, but we'll do that after appending the first number. Okay, so that we can prepare this current min for the next value. So we will update it right here, and that will be with the, not with itself. Current min is appended. It has been appended right here, so it will be with n. Okay, I think this is good. So let's run it on our examples. All right, that's awesome. Awesome. Yeah, it's one of the hardest problems that I've solved. Okay, time complexity would be big of n here, iterating over the all the integers just once, and we're doing some pops, but this is not really happening for each number, so that we can turn it into, either the worst case would be it's either happening just 2 into n times. Don't get confused because of this while loop inside this for loop. Think of it as it's only popping the numbers that we have appended to it. So worst case, it can pop all the numbers that we appended so far, seeing the greatest number in the end, and we never find a solution, return this true. So for 2 into n times it has pushed, n times it has popped. So n plus n, not n into n. Okay, so space complexity here will also be big of n. Number of elements in the nums. Okay, let's go back to AlgoYogi, mark this our last stack problem solved. In future, I can add more problems, which would be hard problems. So this is basically you want to track your own problems that you have solved. So keep doing it. And I think what I'm thinking of adding to AlgoYogi is that an ability for the users to add their own problems. Okay, so you can take the LeetCode link or the title and add it to your own category. So you can create your own category and all the problems that you have solved. So that's something actually really cool. I'm going to implement that. And why not?